Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends, to your younger brothers and sisters, and to your friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies as part of your preparations to engineering life, then please don't forget to subscribe. Level 132, determine the products of inertia of the area of the quarter circular ring, about the XY axis, and about the XO-YO axis through the centroid C of the ring. Treat B as very small compared with R. So here is the given figure. In fact, we already solved this in our preceding slides, level 122. But this time, we also compute the product of inertia with respect to this centroidal axis XOYO of this ring, quarter circular ring. So for our solution, the, the product of inertia of this ring, of this orientation, from level 1 to 2, this is the figure, is capital R cube thickness over 2 from level 1 to 2. So IXY equals capital R cube T over 2. So here, IXY is equal to small r, because this is small r cube, thickness is B over 2. So that's the answer for IXY. And you look at my solution from level 122. Then, with respect to the centroidal axis product of inertia, XOYO, and then from distributed forces, centroids, center of gravity, also from this playlist on statics, this distance is 2r over pi, and this is also 2r over pi. So you have to remember that. If you cannot remember, you look at the playlist where this problem belongs for the location of centroid of circular rings, especially quarter circular rings or semicircular ring. So this will be the distance 2r over pi, 2r over pi. So by transfer formula, Ixy equals I barred xy plus length area of the wire barred x barred y. The area of the wire, by the way, is equal to this perimeter or circumference, which is only 1/4 of 2 pi r. So 2 pi r over 4 is pi r over 2 times the thickness of this ring or this uh, quarter circular ring. So again, the area is pi r over 2, the length of that arc, times thickness b, then barred x to r over pi, barred y to r over pi. So r cube b over 2 equals I barred xy plus quantity pi r over 2 times b times 2r over pi times 2r over pi. So simplifying, r cube b over 2 equals IXOYO plus 2r cube b over pi. So these are like terms. Factoring out r cube b over r cube b, then we have IXOYO equals 1/2 of 1/2 minus 2 over pi r cube b over, that's it. IXOYO is equal to quantity 1/2 minus 2 over pi r cube b. Level 133, determine the product of inertia IXY for the plane region. So we have a quarter circle and this rectangle. No problem with the rectangle because we just apply transfer formula. For this quarter circle, you have to recall that I already solved this, derived the formula for IXY, in fact also for I barred XY. So for our solution, recall from uh, IXY of this quarter circle is equal to r to the 4th over 8, and the product of inertia with respect to the centroidal axis if you recall, is 1 over quantity 1 over 8 minus 4 pi over 9, 4, 4 pi over 9, or 4 over 9 pi, quantity r to the fourth. So 1 over 8 minus 4 over 9 pi r to the fourth, which is negative 0.016471 r to the fourth if expressed in decimal. So here ixy is ixy of the quarter circle, which is r to the fourth over 8, then plus ixy of this rectangle, which is with respect to the centroid by transfer formula 0, then area 6 by 3, barred x 3, barred y negative 1.5 half of 3. So ixy equals 6 to the fourth over 8, then plus 0 plus area 6 times 3, barred x 3, barred y negative 1.5. Combining ixy of the composite area is equal to 81 inches to the fourth. Level 134, calculate the product of inertia of the shaded area about the xy axis. So here is the figure. So for our solution, we recall from previous slides that we already derived the product of inertia for triangles in this orientation. No problem with the rectangle. This orientation, as with respect to xy axis, b square h square over 24 positive, but with respect to the centroidal axis, negative b square h square over 72. So from level 107, so we divide the areas into two rectangles and two triangles of this orientation, which matches with this formula here. Ixy for the triangle b square h square over 24 with respect to the centroid, which is important here because we're going to apply parallel axis theorem for product of inertia. Negative b square h square over 72 for that orientation. So this orientation, so we apply this for these two triangles here, but one by one. So ixy equals, for these rectangles, the area is 6 times 4, 24. Barred x for this triangle is half of 6, so positive 3. Barred y is negative 2 because this is the x-axis. For this rectangle, with respect to the centroid 0, barred x is 6 plus half of 6, 3. So 9, positive 9. While barred y for this rectangle is negative 4, then negative 2. Half of 4 is negative 2. Is 2, so negative 6. For this triangle, the area is 1/2, 6 by 4, 12. And barred x is 6 inches plus 1/3 of 6, so 8. For barred y, negative 2/3 of 4, negative 8/3. While for this triangle, the area is also 12. Barred x is 2/3 of 6, so 4 inches. Barred y is negative 4, then minus 1/3 of 4. Negative 4 minus 4/3 is negative 16/3. So that's 24, 12, 12. These are areas. So ixy equals, for the first rectangles, with respect to the centroidal axis 0, area is 24, barred x is 3, barred y is negative 2. So that's checks. For this rectangle, with respect to the centroidal axis 0, barred x is 6 plus half of 6, 3, so 9. Barred y is negative 4 and negative 2, negative 6. So plus quantity 0 plus 24 times 9 times negative 6. For this triangle here, with respect to the centroid, negative b square h square over 72, so negative 6 square 4 square over 72, plus area 12. Barred x is 6 plus 1/3 of 6, so 8. Barred y is negative 2/3 of 4, negative 8/3. So plus negative 6 square 4 square over 72 plus 12 times bard x 8 bard y negative 8 thirds. For this triangle here, with respect to the centroid, negative 6 square, 4 square over 72, area 12, bard x is 2 thirds of 6, so positive 4, bard y is negative 4, and negative 1 third of 4, negative 16 thirds. So plus quantity negative 6 square, 4 square over 72, plus 12 times 4 times negative 16 thirds. Simplifying, ixy equals negative 144, negative 1296, this one is negative 264, and this one is negative 264 also. Therefore, ixy equals negative 1968 inches to the fourth. Level 135, calculate the product of inertia, I bar xy of the shaded area about the centroidal axis. So I'll present two solutions here. First, let's locate for our solution the centroid, and let us locate it there at C. So let's divide the area into this manner, horizontal. So 30 times 15 is 450, 45 times 12.5 is 562.5 mm square, 40 times 10, 400. So bard x is 15 for this area, bard y is 10 plus 45 plus 15 over 2, so 55, 62.5 bard y. For this area here, bard x is half of 12.5, 6.25, while bard y is 10 plus half of 45, 22.5, so 32.5. For this area, bard x is 20, bard y is 5. So area equals 450 plus 562.5 plus 400. So the area is equal to 1412.5 mm square. Then we apply Varignon's theorem, area times bard x equals area 450 times 15 plus 562.5 times 6.25. 450 times 15 plus 562.5 times 6.25 plus 400 times 20. So bard x is equal to 12.931 mm. For bard y, 1412.5 bard y equals 450 times 62.5. Again, 62.5 is 10 plus 45 plus 15 over 2. That's 62.5 plus 562.5 times 10 plus half of 45, 22.5, so 32.5. 562.5 times 32.5, then plus 400 times 5. So bard y is equal to 34.270 mm. Then product of inertia with transfer, so with respect to the centroid 0, so area bard x bard y would be the term with value. So ixy for area 1 is 0 plus 450 times 15 times 60, quantity 15, because with respect to the centroid, 15 is the centroid of the area, so to be consistent, then minus the bard x of the entire area. Then bard y is bard y of the area, then minus the bard y of the entire area, to be consistent, so you will not think anymore. Plus, for this next area here, with respect to the centroid 0, plus 562.5 times 6.25 minus 12.931 times 32.5 minus 34.27, plus this area here with respect to centroid 0, area 400 times 20 minus 12.931, quantity times 5, it's y here is 5 minus y bard y of the entire area 34.27. So computing one by one, ixy equals 26283.54 plus 6651.77 minus, this is negative 82763.85. So I bar xy is equal to negative 4000 49,830 millimeters square. For the other solution, let's compute for ixy of each. Let's transfer it to xy axis. Then let's apply parallel axis theorem to solve for I bar xy. Anyway, we already computed bar x and bar y. So ixy equals I bar xy plus area of the entire region bar x bar y. So that's simpler in this situation. So ixy equals 0 for this rectangle here. Then 450 bar x is 15, bar y is 62.5. For this rectangle here, with respect to the centroid 0, plus 562.5, bar x 6.25, bar y 32.5. Then for this rectangle here, with respect to the centroid 0, bar x 20, bar y 5. So ixy is equal to 42,1875, first term, second term, third term. So ixy is equal to 576,133 millimeters square. Then substitute into I bar xy area bar x bar y. I bar xy plus area bar x bar y. So 576,133 equals I bar xy. Area is 1412.5. Bar x is 12.931. Bar y is 34.270. So to four significant figures, I bar xy equals negative 49,810 mm square. So they are practically equal. And the reason for that, the very slight difference, it's 20. Do you think 20 mm to the fourth is large? No, because if you compare that to the value, it's very, very small. So that's it for this problem.